Happy New Year guys, welcome back to Kit Guru. I'm James and I hope you've been enjoying some rest and relaxation during the holiday period. That's exactly what I've been doing, but it's a new year now. It's time to get back down to work again with a new project. Those of you that are regular viewers of the channel may have seen the Seasonic Aura project that we finished off just before the Christmas break. That was a large custom built system using just standard ATX parts, but we also had some laser cut panels, custom power supply shroud, custom cables, and a really elaborate custom water cooling system. If you've not seen that project, make sure you check that out. It's really interesting. But towards the end of that project, I saw a lot of comments on the channel asking if we could cover a small form factor system next time, and that is exactly what we'll be doing to kick off the new year. But before we dive into the details of this new project, I just quickly want to remind you guys to subscribe to the Kit Guru channel if you like this video. Hit the like button and also hit the bell button to get notifications. If you want to help support us in other ways, you can always head over to our store, pick up some Kit Guru merch. We'd really appreciate that help. And as always, you can head over to the kitguru.net website where you can catch up on all the latest tech news and all the latest gaming and hardware news. And you can connect with us through our social media channels such as Facebook, Twitter, Instagram, and you can connect to our Discord channel. For this new project, we've partnered up with Intel, and we're going to be building one of the smallest small form factor gaming systems inside this Cooler Master NC100 chassis. This chassis is designed for the Intel NUC, so we've got our hands on an Intel NUC 9 Extreme. This is the one with the i9 9980HK processor, and we're going to try and build the most powerful gaming system we can into this tiny chassis using this GeForce RTX 3080. Now you might think that that sounds pretty simple and straightforward, this NC100. It is designed to take the Intel NUC Extreme card and also a graphics card, so it sounds pretty simple, doesn't it? Just build it up inside there and you'll have a pretty hot gaming system. And that is one of the reasons why this is a project rather than just a build, because hot is the relative word. It's going to get pretty toasty inside there with the 3080 and with this 9980HK processor. So the main aim of this project is to try and water cool the whole system. Now that's obviously going to be very difficult. I think this chassis is a capacity of like 7 litres or something like that. So it's going to be difficult, or it's going to be quite a challenge getting all the water cooling parts inside that system. And obviously this NUC 9 Extreme board isn't designed at all for water cooling. There's nothing off the shelf you can buy to water cool this system. So it's going to be a challenge, but we're always up for a challenge here at Kit Guru. Our plan for this first video is to have a look at this NUC 9 Extreme compute element card in a bit more detail, see what we've got to play with on that board, and also take a look at this NC100 chassis, see what space we've got inside, if any. Have a look at the power supply as well, because this 3080 is going to be quite power hungry. I think I might try and change the power supply in that to a Seasonic unit. We may have to customize some cables or even customize the power supply. Who knows yet, because I don't really have any experience of working with these Intel NUC systems, so it's a learning curve for me as well. But it's going to be interesting. So let's have a look at this NUC 9 Extreme compute element card first, see what you get with the card. So the compute unit we have is a pre-production engineering sample. So inside the box, all you basically get is the compute card and a standoff for what looks like an M.2 drive. But there's a lot of technology on this board. It's basically a whole PC on what looks like a PCIe card. Let's have a look a bit closer under the hood and see exactly what we've got in here. So the top cover's just held on with 4 screws, and inside you can see there's a small fan there. There's 2 heat sinks for the onboard M.2 slots. And then if you look a little bit closer, you can see there's 2 DDR4 SODIMM memory slots, and you can see there's also 2 M.2 slots on the board there. With the base board, that this plugs into that comes from Intel, there's a third M.2 slot. So there's loads of storage options available. There's also a single SATA connection on there, so you can install a 2.5 inch SATA drive. That's not what we'll be doing. We're just going to use two M.2 drives in this system. And then the big copper slab you can see here, that is the heatsink for the CPU. There's a vapor chamber in that, and then at the top is a small fin stack there, and obviously the fan blows on that and pulls heat away from the CPU and probably a little bit from the memory as well. Also up at the top corner of the board here you have a onboard audio header, and then on this side of the board you can see there's a 4+4 pin standard EPS power connector, USB Type-C header. We have two USB ports on this NC100 case, so we'll use that Type-C header. There's also some fan headers and a front panel connection. The board also has built-in Wi-Fi. You can see there's some Wi-Fi antennas there, and these are some connections where you can put an external antenna too. And then on the back of the cord there's two Ethernet ports, four USB 3.0 ports, HDMI port, because obviously this 9980HK includes integrated graphics, so technically you could just use this board on its own. You don't need any discrete GPU and you have a complete system there. Also on the back of the card there's two Thunderbolt 3 ports and an optical audio output. On the back of the board are 4 screws. I'm just going to remove these screws. And then a 5th screw on the other side should allow us to remove the whole fan shroud. There's a BIOS battery there that just plugs into the board, and then if you just pull out this fan header, that's the whole plastic fan shroud removed. And then you can see a little bit closer at this heatsink fin stack, and that's all that is cooling the system, or all that's cooling the compute element. And you can see I think the heatsink actually covers the VRMs, and it also covers the chipset underneath this heatsink fin stack. So it doesn't look like we've got a huge amount of space there to install water cooling. I think we're going to be quite restricted because it's very close to the memory on one side and then even closer to the M.2 slot on the other side. So it's going to take a bit of working out. We'll probably try and reproduce this shape of this vapor chamber and maybe make some kind of adapter plate or integrated heat spreader, and then just try and fit on top of that an off-the-shelf CPU water block. Whether that's going to work, we're not sure at the moment, but we'll dive into that later once we've tested the system out and just seen what kind of heat we're generating and what kind of turbo boost speeds, because this 9980HK, it runs at a base speed or a base frequency of 2.4 GHz with a single core boost of 5 GHz. So the main aim of this project really is to try and cool that CPU down so that it has a higher sustained boost. We'll be able to run the power levels hopefully a bit higher with water cooling, and that should help the performance. And we're not really going to be trying any manual overclocking, so I'm not even sure that manual overclocking is possible with this board, but it's basically just going to be trying to raise the power levels to keep the boost sustained for as long as possible, which should help in gaming, and that's what we want. We're trying to build the highest performance, small form factor, water cooled system here, so that is the plan. Whether it's going to work, we'll find out shortly. As well as water cooling the system, I'm also planning some mods for this case. Some of the mods will be forced upon us because of the water cooling. I'm pretty sure that not all the water cooling components are going to fit inside this case. I think a radiator might have to be externally mounted. We don't want to change the size of the footprint or really make this system, like the overall size of the system, much bigger. It still needs to be a small form factor. We can't end up with a massive thing that's bigger than an ATX system. I originally was hoping for a white version of this case. Cooler Master do these in white and black, but unfortunately the white one was proving quite difficult to get hold of, so we've ended up with a black one. I think I'll probably end up doing some kind of custom spray job on this, either that or having it powder coated. I'm leaning towards the custom spray job more at the moment. It'll probably end up being a white and blue theme with blue accents to kind of fit in with the Intel theme. So first of all, we need to have a look inside this, see what kind of space we've got to work with. Take a look at the power supply. I think it's a 650 watt unit, which might be pushing it a bit with the 3080, so I might swap that out for a better quality Seasonic unit. Obviously, if that's the case, we'll have to make some custom cables, maybe modify the power supply as well. So there's lots to do in this project. It's not something that's just going to be, done in a day. It's going to take several weeks or months depending on how things go. But first, let's have a look inside this chassis and see exactly what we've got here. It's an extremely small unit. I think the capacity is about 7 litres or something like that. So there's on the back, you can see there's thumb screws that hold all these panels on. You can just slide the top panel back. Then on there's 2 slimline 92mm fans. They are the only fans that come with the system. I'm going to try and repurpose those for the water cooling. We have a 2x92mm radiator from Alpha Cool that will be used for that. So take off the other side panel. Again, 2 thumb screws. That panel just slides backwards. Inside there we have a box of accessories. I'll take a look at those accessories in a bit, see what we've got. Also some bits of foam inside here. Same again for this other side panel. 2 thumb screws. It just slides off. It's pretty easy to get into, and you can see when you get all the side panels off and the top panel, plenty of space to get your hands in and work, so that's a good start. The majority of this chassis seems to be made out of steel, and it feels really sturdy, so looks like decent quality from Cooler Master. The front panel is actually plastic. That just pushes off. 2 USB Type A ports on there, a front panel audio connection, and then there's a small reset button down at the bottom of the case there as well. The power supply is mounted on a bracket, and there's 2 screws at the front, and then 2 more screws on the side here. The bracket just locates on a little tab, so if you just pull it backwards, that just releases the power supply. And then there's a kind of a extension cable that goes from the power supply to the rear of the case. The power supply that comes in the NC100 is a pretty standard looking SFX unit. I think this is just a standard Cooler Master V650 SFX 650 watt 80 plus gold unit. Probably not a bad power supply, but I think I'm going to try swap this out for a Seasonic unit, because we know the quality of the Seasonic power supplies maybe a little bit better than the Cooler Master ones. In terms of cables, 18 and 10 pin connection here. These would normally go to the ATX 24 pin connection, so that's quite different to what you would see on a standard SFX power supply. It's just a 10 pin connector there. I think there's just 12 volts and ground at that connector, and that plugs into the Intel base board. We have a pretty standard looking SATA cable there. It's obviously shorter than what you'd normally get. There's also a EPS power connector 4+4. Again, that pretty standard, that cable, just probably a little bit shorter than what we'd normally have. And then there's a single PCIe connector. There's obviously a couple of spare connections on the back of this power supply, but I don't think Cooler Master's really expecting you to be running 2 graphics cards inside this system, so these are all the cables that are provided. When we swap this power supply out for the Seasonic unit, if it works, we're going to be having to make some of our own custom cables, because obviously Seasonic, they don't make a power supply for the Intel NUC. In fact, the power supply we'll be using will be this Seasonic Focus Gold SGX 650 unit. It is the same 80 plus gold, 650 watts, but we do expect, the quality of the capacitors and the internals of this power supply to be better. So it should be able to handle the power of this RTX 3080, hopefully better than this Cooler Master unit. So we'll have a look at that again later in the project. It'll probably not be far down the line that we have to start taking a look at this power supply. But before I start modding or messing around with the power supply, I'm going to stick this back in the case, build the system up, in its stock form using this power supply, and then we'll take some readings of power draw, see what kind of temperatures we're getting with the system in its stock form, so then we can compare the temperature and the boost frequencies and just the overall performance after we've completed the water cooling. To build up the NUC 9 Extreme using the stock cooling, you're obviously going to need the compute element card, a suitable chassis such as the NC100 from Cooler Master, a suitable power supply such as the one that comes with the NC100, but you're also going to need some memory, so we're using 32 gigabytes, 2x 16 gigabyte modules of this G-Skill Ripjaws DDR4 SODIMM memory. The compute card supports 2666 memory, but it also supports Intel XMP profile, so this is 3200 megahertz, so this should work perfectly with the compute element card. You're also going to need some storage, so we're just using two of these 2 terabyte XPG SX8200 M.2 NVMe drives. These are PCIe Gen 3 by 4. No point using Gen 4 because this doesn't support PCIe Gen 4. And if you're going to be doing something graphically demanding, you're going to need a graphics card, so we're using GeForce RTX 3080, the 9980HK CPU that is soldered onto this compute card. It comes with its own integrated GPU, so technically you don't need this GPU, but if you want to do some gaming or if you're doing some editing or anything graphically demanding, you're going to need a discrete GPU as well. So first thing probably to do is install the memory and the M.2 drive, so you just need to remove these 2 screws on this top cover. Just lift that top cover off, and that allows you access into the memory modules and the M.2 drive. So we'll install the memory first. This is just normal SODIMM laptop memory, so this just installs in the same way that it would do in a laptop. So we've got 2 16 gigabyte modules, they just clip into place there. Next we'll install the M.2 drives. The compute element board, it has 2 M.2 slots, you can see right there. If you get the stock Intel baseboard, the baseboard is this board that you can see here. The compute element card plugs in here and your graphics card plugs in the other PCIe slot. But if you use the stock Intel baseboard, that actually has a third M.2 drive. Unfortunately the Cooler Master one doesn't, so we're just stuck with 2 M.2 slots on the compute element card, but that'll be enough storage for what we need for this gaming system. 2 terabyte drives should be good enough to hold enough games for a while. If you do need additional storage, there is always a SATA port, so you can add a 2.5 inch SATA drive to just give you a bit more storage. So as is with any M.2 drive installation on just a stock motherboard, you just need to remove these screws. Obviously one of these drives will be used as the operating system, so we just install the first drive in one of the slots, hold it in place with the retaining screw. These XPG drives do come with a small self-adhesive heat spreader, but for now, while we're using this stock cooling configuration, we have these 2 heat sinks built into the top cover, so we'll use those for now. And then the second M.2 drive just goes right next to the other one. Same again, just fix it in position with the retaining screw. And for now we'll remove these pieces of plastic that protect those heat sinks. Pop the cover back on. And then tighten the screws up again. So that is basically all the preparation needed for the compute element card. That's ready now to slot into the chassis. So I'm not 100% sure whether it's easier to fit the power supply first and then plug in the element card and the graphics card, or whether it's easier to do it the other way around. So I'm just removing as many things as possible at the moment. So I'm going to take off this power extension lead as well, because this does look like it could possibly interfere with installing the cards. So there's 2 screws that hold this on the back, and you can take that out. Then this long cable here is the front panel audio connection, and there's a smaller header here for the front panel connections, such as the power button, reset button. There's also an RGB cable here as well, because on the base of this case there are some RGB LEDs down there. And then in the accessory box there's a few more cables. Front panel USB Type C cable. There's a fan splitter cable that plugs into a proprietary header on the board, so we'll need that. You also get a few zip ties and an RGB lighting controller as well. There's also a spare screw in there for something. And also in the accessories is this shroud that kind of is used to direct the airflow up to the compute element fan. I don't think we'll use that for now. You also get a power cable, which is handy, and a magnetic dust filter for the bottom of the case as well. So to start installing these cards, we just need to take 2 screws out of the back of the chassis, and remove this panel, and then the element card should just slot in pretty much like any other PCIe card does, and it just clicks into place as you would expect. I think while we're here, connect up this front panel audio, and also connect up the front panel header to the motherboard. I think as well we use this fan splitter cable. Just connect that up to the fan header. The fan header is this longer connection on the compute element board. I think we'll try and fit this power supply in now. There's not a lot of space for this, but for now this is just going to go back in its normal stock position. We'll connect that 10-pin power connector to the baseboard, and also connect up the 4+4 pin EPS power. That's all connected up. In its stock configuration, the power supply fan faces the inside of the case, kind of away from this side panel a bit. When I try and install the water cooling, I think I'm going to see if I can spin the power supply around so the fan's facing this back panel, and hopefully I'll be able to draw in some cold air from outside and then exhaust the warm air out through the top, rather than pulling in potentially warm air from inside the system. We'll have a look at that later though, and whether that's possible, I'm not sure. That also maybe potentially might give us a bit more space to work with inside the case to install a small pump res combo, or just something extra that we might need inside the case for the water cooling. But for now, while we're just doing this test build with the stock cooling, I'm just going to try and install the power supply in its stock configuration if there's enough space. It is really tight, that power supply, up to that EPS power connector. It looks like it just manages to squeeze past to install the screws that hold the power supply in position. So that's the compute card and the power supply in. I guess we may be able to reinstall this power connector now. That's that back in place. Try and move as many cables out of the way to make space for the graphics card. That's it, that's the PCIe cable. Just want to try and push as many of those cables out of the way. SATA power cable, we don't need that for now. We're not connecting up the RGB or any other storage devices. Let's try and install the graphics card. According to the specifications, this card should drop in place. Just need to remove these two PCIe covers off the back. Both of those out of the way. Pull that fan cable out of the way as well. So, it doesn't go in from the top. It needs to go in from the side. It seems to be in correctly. Obviously with the Founders Edition RTX 3000 series, you need this 12-pin power adapter. That is something else that I'll be looking at making a custom version of, because I don't really like the look of that. That needs to be changed. Obviously this graphics card takes up a lot of space inside this chassis, and it doesn't look like there's much room in there to fit any water cooling. But when we take off this stock heatsink and fan, the card is actually only about 200mm long, so the card will end around here. So that may give us just some space to the side next to the power supply to hopefully install some kind of pump res combo. But for now, I'm just going to use the 12-pin adapter just to make sure everything's working as it should be. So just connect those up. Luckily we have two 8-pins to connect up to. That's one. That's both of those connected up, and as you can probably see, that does look quite messy and takes up a lot of space, and I'm not really sure what NVIDIA were thinking of with that 12-pin power connector. Surely there could have been a better way to resolve whatever problem they had with that, but it fits at least anyway. So that is more or less the system built up. Just need to connect the fans up to this splitter cable. Connect those two fans up. See if we can fit this top cover back on. Yep, that looks like it goes on alright. That seems to fit okay. Put the screws in the graphics card. And the element card is just held in place with a single screw, even though it takes up 2 slots. So that's that back in position. Just put this cover plate on temporarily. So that's it, project complete. We have a nice powerful NUC gaming system. Just kidding. But that is, I mean, if you were just building this up with the stock cooling, that is basically it. That is how easy it is to build a system inside one of these NC100 cases, and you've got a pretty high spec gaming PC right there. But as I've said before, we like a challenge at Kit Guru, so we'll not be stopping there. But for now, I'm going to put all these case sides back on and just see what kind of boost speeds and see what kind of CPU frequencies we're getting, and see what kind of GPU frequency we're getting as well when the GPU is under load. See what kind of temperatures the system is running at, and then see if we can improve that with the water cooling. We've had a couple of minor setbacks. This is partly one of the reasons why I like to do a test build using all the stock parts before moving on to any mods in these kind of modding projects. It's always a good idea to build the system up first with the stock parts, just to make sure everything's working right. So initially, building the system, assembling it, was really simple. I was really surprised at how easy that is. Installing Windows as well, that went really simple and straightforward. It's just like installing on any other desktop system. The problem, or the initial problem, was these XPG M.2 drives. For some reason, once Windows had been installed and you were just trying to work in Windows normally, the system was really unresponsive. Task Manager was showing like 100% disk usage, and Crystal Disk Mark measured the read speed at something ridiculous like 1.5 megabytes per second. So there seems to be some kind of compatibility issue with those XPG drives and the NUC board. I tested them on a different system and they seem to be working fine. So that is one problem. That's resolved. I ended up using a Plextor M9 drive, put that in, everything worked perfectly. So after I'd resolved that problem, I was just plugging the power back into the system again, and as I was just plugging the mains cable in, the Cooler Master power supply seemed to have expired. It went with a massive bang and a flash, so that seems to be dead. Apparently there was some kind of issue with the pre-production units of this NC100 that was to do with the power supply, so I'm guessing this is a pre-production unit and that's why this power supply is blown up. But it's not a big problem. It kind of pushes me into trying to modify this Seasonic unit to fit in the NC100. I was hoping that I'd do this a little bit further down in the project, but we may as well just crack on with that now because I don't have a spare one of these. The only problem with that is I wanted to use the Cooler Master power supply kind of as a reference to figure out if the pinouts on the back of the power supply are the same between the Seasonic unit and the Cooler Master one. But luckily I've managed to find some pinout diagrams. Looking at these diagrams, it turns out that the 18 pin and the 10 pin on the Focus, the Seasonic Focus unit, which usually would go to the 24 pin ATX connector, the pinout on those is the same as the Cooler Master one, which is really handy because this distributes the power to the 10 pin connector on the baseboards. And that's good news because it means I should just be able to use the power cable that came with the CM unit. So this is the 18 pin and 10 pin connector that would normally go to the 24 pin ATX connection. I should just be able to connect that straight up to the Seasonic unit, and we'll at least have the pinouts correct for the 10 pin power connector on the baseboard. So just to be certain that the Seasonic pinouts are correct according to this diagram, I'm just going to test them using the multimeter. So what I'll do is just take the original 24 pin connector that comes with the Seasonic SGX unit, connect up one of these 24 pin test connectors, then plug this in to the power supply. Plug the power supply into the mains, turn it on at the back, so that actually starts up the power supply. It kind of jump starts it as if you would be pressing the button on your PC case. Now that the power supply is turned on, we can check the pinouts of the 24 pin connector against this diagram, and there's just a small section that shows the pinout at the power supply side, which is what we need to know. So if we just set the multimeter to 20 volts, and then if we just find one of the ground connectors, there's an area in the middle of the 18 pin that are all ground, so stick the negative lead into one of those. I can test if that is a ground pin by just moving the multimeter to continuity and touching the case, and that is ground. So back to 20 volts. So on this 18 pin connector we should have a row of, or two rows of 5 volts at this side. And if you can see the multimeter, that is reading 5 volts when I'm touching these pins. So all those 5 volt pinouts seem to be correct. Next should be a couple of rows of ground connections, so they look correct as well because nothing's coming up on the display of the multimeter. So then further on we have 3.3 volt connections, so there's a row of 3.3 volts at the bottom of the connector. That's 3.3 volts. So is the next one and the end one, so that the bottom row of 3.3 volts is correct. See if I can get to the top row. Should be 2 at the end at 3.3 volts. That's one. That's the other one, so they're all correct. So all the pinouts on the 18 pin connector seem to tally up with this diagram, so that's a good start. Put the negative probe back in a ground connection and have a look at the 10 pin connector. So the bottom row, the first two should be 12 volts. Both of those are 12 volts. The next one is minus 12 volts, which is correct according to the multimeter. The next pin should be 5 volt standby. That's correct. And there's also power good, which is 5 volts. Power on switch. And on the top row we should have 3 grounds. 1, 2 and 3. And then 12 volts, which is the same as we got. And then the last one is the power on switch. We know that's right because it connects up to this 24 pin test connector, and we can just trace that up to that test connector to make sure that's right, and it is. So that's good news. The 18 pin and 10 pin connector on this Seasonic unit is the same as this Cooler Master one, so that means we can just use the stock Cooler Master cable that came with this. Maybe down the line I might change that cable a bit, I might sleeve it or something like that, but for now at least we can carry on with testing the system using this Seasonic unit. I've also test fitted this inside the case, which you'll see in a bit, and it fits just, it's obviously a bit bigger than the Cooler Master unit because this is an SFX power supply and the Seasonic unit is an SFX L power supply, and you can see it is a little bit longer, but there is enough space inside the case for it, so that's good news as well. We also need to just check that the other cables are the same, so the EPS connection, the 4+4 power connector that goes onto the element card, and obviously PCIe, they should be the same. I think they are just standard PCIe cables, just obviously shorter, that come with this Cooler Master power supply, but we'll check those anyway. We know that the 18 pin and 10 connections are the same on both of these two power supplies, so what would have originally been the 24 pin ATX connector, which is now just a small 10 pin connector that goes to the baseboard, that is perfectly fine to use the Cooler Master cable on this Seasonic power supply. The other thing we need to check out is the pinouts of this 4+4 pin EPS connector that came with the Cooler Master power supply, and just check that the pinouts are the same on that, or at least that at the motherboard end or at the end that goes into the Intel NUC, at least make sure that the voltages are the same between the Cooler Master and the Seasonic cable. According to the diagram at the motherboard side, the cable should be the same, so it is just a regular 4+4 EPS connector. But at the power supply side, we can see that the 12 volts and the ground pins are kind of swapped round. So to use this shorter 4+4 EPS power cable that came with the Cooler Master power supply, to use this with the Seasonic power supply, we're gonna have to switch some of these pins round. Not only are the pinouts different on these two EPS power connectors, the actual connector housing is a different shape. So if you try to take this Cooler Master cable and plug it into the Seasonic power supply, it just doesn't fit. So the first thing we need to do is completely remove this connector from the Seasonic cable, and you may have seen me use this method before with the staples, so just need to take some normal staples and just push those down either side of the pin in the connector. So push one down either side. That just pushes some little tabs back on the pins, and then you can just pull the wire out. So we need to take all these pins out of this EPS connection. So to get this connector off completely, we obviously need to do that for all the pins. So there's 8 pins to go at, so this will take a minute. So that's the 8-pin EPS connector removed from the Seasonic cable, so we can set this Seasonic cable aside now. Then we need to remove the 8-pin EPS connector from the power supply side of the Cooler Master cable. So we just do that in the same way, using the staple method. That's the connector housing off the Cooler Master cable. So now we need the connector housing from the Seasonic cable, and we just need to reconnect the pins in the correct orientation for the Seasonic power supply. So back to the multimeter again, set to continuity, and we know that the top row of pins where the locking mechanism is, they're 12 volt connections. So if we pop one of the probes from the multimeter to one of those top connections and just find the other end, so that is one of the 12 volt connectors. So on the Seasonic power supply, at the power supply side, 12 volt connections are in the bottom row. So we'll just plug that one into the first one, like that, and move on to the next one, which is that one. That can be pushed into the second, then onto the third one, which is this wire. We can put that next, and the final 12 volt wire is this one, so that goes in to the final one at the power supply end. Just same now with the other side, so these are all the ground connections. So again, one of the probes from the multimeter, and you see that one is the first ground, so pop that in at this end. These obviously should all be grounds that are left. That's the second one. Pop that one in. That's the third, and there's only one left, but just make sure that's right. So that's it now. The original Cooler Master 4+4 pin EPS cable now has the Seasonic end on that plugs into the Seasonic power supply. So we'll just test this. So connect that up, set the multimeter to 20 volts. Can just hold the negative probe onto the casing of the power supply. So the top row of the connectors, we should have 12 volts in all pins. Which we have. And the bottom row should all be ground, so there should be no reading. In fact, we can check to see if they're ground by setting the multimeter again to continuity. We should get a bleep on every one, which we do. So that cable's now all correct, and we'll be able to use this power supply in the NUC. And then the PCIe cables, obviously they're different lengths. So the one that came with the Cooler Master power supply, that's obviously the shorter cable, but not only is the length different, as we saw with the EPS connector, the connection that plugs into the power supply side, that is also different on the Seasonic power supply compared to the one on the Cooler Master one. So for now I'm just going to swap the connectors around like I did with the EPS connector and just use a single power cable just for testing the temperature and boost frequencies of the graphics card. But when we come to actually build the final system, I want to use two separate power cables, and also I want to make a complete custom cable, because obviously on the RTX 3080 you've got that funny 12 pin connector, so I don't want to use that 8 pin to 12 pin adapter cable. In the final build I'll make my own custom 8 pin to 12 pin connector that goes direct from the power supply to the graphics card itself, and we'll probably sleeve that in some PET sleeving as well. So, but for now, just going to do the same method as I did with the EPS cables and just swap these connectors around just so we can get the system up and running to do some testing. Okay, so that's the original Cooler Master PCIe cable modified to suit this Seasonic power supply. So basically we've just put the Seasonic connector on the end of the Cooler Master cable. So I'll just plug this into the Seasonic power supply. And again, just use the multimeter just to test that we've got these pinouts correctly. So on a PCIe connector, the top row, they should all be ground. The bottom row, 3, should read 12 volts. Which they do, so I'll just switch to resistance. I've got the negative lead connected up to a ground pin. So if I just check resistance of the top row, we hear a bleep on all those, so all those are connected to ground. That's the PCIe cable ready. Obviously, like I mentioned, I'm going to do some improved, modified PCIe cables in the final build. But for now, this Seasonic power supply, it should be ready to be installed into NUC, and hopefully, fingers crossed, we'll have a system that works and a power supply that doesn't blow up. So the system's almost back together with the Seasonic power supply installed. You can see I've flipped the power supply around the other way, so the fan is now at this side of the system. Hopefully then we'll be able to pull in some cool air from outside and expel that out at the top of the system. Something else I've noticed when I was just about to refit this power supply extension cable, when the Cooler Master power supply exploded, it did some damage to this this connector on here. You can see that one of the terminals is a bit charred, so it actually must have flashed as well here as well as in the power supply. So luckily I've got a spare one, so I'm just going to use the spare just in case, just make sure there's no permanent damage that can be caused if I use that damaged one. So luckily I've got a spare. So I'm just going to install this, install the graphics card, and hopefully the system should be up and running again. System is almost back together. There's just one very slight problem because of the Seasonic power supply being a bit longer than the Cooler Master one. When you go to put the front panel back on, it clips on except for just the bottom corner. The clip down in that bottom corner is actually pressing up against the power supply before you can fully push it home. So I think I'm just gonna have to probably take a bit off that clip, probably just take it down on the bench grinder a little bit and see if we can get it fitted and it's still been nice and secure on the front of the case. So I'll just see if I can grind that down on the bench grinder a bit and see what happens. So that clip on the front panel, it just needed a couple of millimeters grinding off. That was pretty simple, and now you can line that up, clip it on, it fits in place, lines up well, and it's nice and secure, so that's good. I've just left the top panel just hanging on the case, but I have connected the fans up, and now it's time for the moment of truth and see if this Seasonic power supply that we've shoehorned in and modified the cables, see if it actually works. So switch it on at the switch. Nothing seems to be smoking or exploding or setting on fire at the moment, so that's a good start. And just power the system on and see what happens. So we've got some lights on the graphics card, so that's good. And it looks like it's booting up, so that is really good news. It's booting into Windows. That looks good. And it's working, and we've still got that makeshift SSD that I had to put in just for test purposes, but Windows has booted up. So what I might do now is I might just try these XPG M.2 drives, see if that power supply has made any difference. I doubt it does. Also I might have a look in the BIOS as well, see if there's any settings that I can change, just to see if we can get those XPG drives working. If not, then we'll swap to some other drives for the final build. Okay, both those XPG drives are installed back into the Element board. We've got Task Manager up in Windows, and you can see that I'm not doing anything, the system's pretty much idle. If you click on things, it's okay, it's not as snappy as I would expect. You can see that's Google Chrome taking forever to load up. If I just want to access files again, it's not very responsive at all, the system, so there's something not right, and you can see the disk usage is shot up to 50%, but not really anything's happening. So still there seems to be a problem with those XPG drives, and as you can see, looking at Crystal Disk Mark, the read speed showing less than 1 megabytes per second, so that's way off the 3,500 megabytes per second advertised speed. So there's obviously some kind of compatibility issue with those XPG drives and the Intel NUC. On my Z390 system, the drives work perfectly, so it seems like it's a incompatibility issue, nothing related to the power supply, which is great. I've had a look inside the BIOS. Doesn't seem to be anything that stands out in there that's configured incorrectly, and obviously when I install this Plextor M9 drive, it's like a completely different system, working perfectly, everything's responsive, and it seems to be fine. In Crystal Disk Mark, the Plextor drive reaches just about its speeds that it should. So one last thing I'm going to check is a BIOS update. I've noticed there is a slightly newer BIOS update for the Element board, so I'm just going to give that a try now. Apparently there are a few different ways you can update the BIOS of the NUC 9 Extreme Element compute card. One of the ways is an application in Windows. I think you can update it through the BIOS itself as well, and there's also a flashback, a BIOS flashback tool as well, so you'll need a USB drive. So I'm just going to pop that in one of the USB ports on the back of the case. Turn the power on. According to the instructions, we need to hit F7, so hit F7 and see if that goes into the BIOS flashback tool. Looks like that's working. You can see the USB drive listed there, and the BIOS file is a .cap file, so that is the latest BIOS, so I'll select that. Process BIOS update. Are you sure you wish to update the BIOS? Yep. Click yes. System's powered off and powered back on again. Now we've got a message saying that the flash update is in process, so you can see the progress bar going up. It looks like it's working as it should do. So the BIOS update is complete. That seems to have gone perfectly well. Windows is back up and running and not really much has changed. The system is still not as responsive as it should be. Chrome's taking a while to load up, and you can see that the read speed in Crystal Disk Mark is still only 2.3 megabytes per second, so that's not looking good. Looks like those XPG drives are just not going to work in this system, so at least we've learnt one thing, that if you're using one of these NUC 9 Extreme boards, don't use an XPG SX 8200 Pro. It's just not going to work by the looks of it. The temporary Plexter M.2 drive is installed back in the system, and I put all the case panels on. Top fans are installed, so I'd say the system is in its like stock default configuration as it would normally be run with a stock cooling and graphics card installed. Everything as it would be in kind of a stock setup. I've been running some IDA64 stress tests, so currently we're just stressing the CPU, FPU and cache just to monitor temperature, frequency. So if you look at these graphs that we've got on screen, down this side you have all the individual core frequencies. This stress test has been running for about 25 minutes now, and you can see that we're averaging roughly 3 gigahertz across all cores now that everything's all up to temperature. The CPU core max is at around 72 to 73 degrees C. The CPU package temperature, that's hovering around about 75 degrees C. Package power currently is at 65 watts because the BIOS is in its default configuration, so the short duration power limit is around 105 watts, and the long duration or the sustained power limit, that's at 65 watts. So when the system's up to temperature, it's set at 65 watts. So that's why we're seeing the CPU frequencies around about 3 gigahertz. When we move on to the water cooling, hopefully we'll be able to raise that long duration power limit to 100 watts, and hopefully it should sustain a higher core frequency. That's what we're aiming for anyway at the end of the project. Currently the GPU is not under any load, so GPU temperature and GPU power and the GPU frequency, that's all insignificant at the moment, but we're obviously logging these temperature and frequency details, so that'll give us a good set of data to compare later when the system's water cooled. So that gives us a rough idea of how the CPU temperature and how the CPU frequency acts while the CPU is under load. So I'm just going to stop that test, or stop that stress test. So stop that. Let the system cool down to just its normal idle temperature. You can see already the CPU temperature is dropping pretty quickly. It's down to like 50, mid 50s. It's still going down, so we'll just give it probably 20 minutes, let the system completely cool down, and then to sort of simulate some gaming performance and measure the GPU temperature and GPU frequency, I'm just going to run 3D Mark Time Spy in a loop for half an hour, 45 minutes, and again we'll have HW info logging all the temperature and frequency information during that gaming simulation. The 3D Mark Time Spy benchmark, it's been running for about 40 minutes now, and obviously the system's all fully up to temperature. There's not been any crashing or anything like that, so that's good. It's been running constantly for 40 minutes. In terms of noise levels, it's not too bad. Whether you can hear that, but it's not too distracting, so that's good to see. That should also, again, hopefully be improved when we water cool the system. If I just drag this out of the way so we can see the graphs. So back again with the CPU core frequency. Obviously the CPU isn't under 100% load during this 3D Mark benchmark, but you can see the boost frequency is somewhere between 4.1 to 4.4 gigahertz. Obviously CPU temperature, because it's not under 100% load, that's hovering somewhere between 69 to 80 degrees, so that seems reasonable, but again, that is at the 65 watt long duration power limit, so like I say, hopefully we'll be able to lift that power limit when the whole system is water cooled. And then in terms of the GPU temperature is currently at 77 degrees. You can see it drops a little when the benchmark stops and then restarts, so when it's running we're looking around about between 75 to 77 degrees on the GPU, so that's not too bad to say that this is in its stock cooling configuration at the moment. And then if we look at the GPU power under load, it's pulling just over 300 watts. I think I see around about 315 watts. So again, that seems pretty normal. And then the GPU boost frequency, we can see at the bottom, that's running around about 1700, between 1660 and 1710 megahertz, which is not brilliant. I'd expect it a little bit higher, especially when we get it water cooled. Again, we should hopefully see those turbo boost clocks increased and be able to sustain a higher boost frequency for longer. So that is, you know, the challenge with this system is to get it water cooled, and we're hoping that when it's water cooled we should see quite a good step up in performance. So those thermal performance tests and CPU frequency tests, it gives us a good set of data to compare against when we do, well, hopefully when we do get the system fully water cooled. I think that's probably where we'll wrap up this video. Spent a long time doing jobs that I didn't expect and kind of troubleshooting issues with power supplies, but at least we've made a bit of progress on the system. We now know how it performs in its stock cooling configuration, and we have some targets to aim or targets to beat when we get the system water cooled, and that's what we'll be looking at in the next video. Obviously, water cooling the GPU is going to be quite simple because there is an off-the-shelf GPU block for this RTX 3080 Founders Edition. In fact, it'll be an alpha cool block that we'll be using. The real challenge will be manufacturing or making something to adapt to CPU block to fit on that NUC 9 Extreme element card. I hope you enjoyed watching the first part of our NUC 9 Extreme water cooling project. If you have, then don't forget to subscribe to the Kit Guru channel, and also make sure you hit the like button and hit the bell button for notifications. And if you want to help support Kit Guru in other ways, head over to our store, pick up some Kit Guru merch. We really appreciate the help, and you can connect with us through our social media channels such as Facebook, Twitter, Instagram, and our Discord channel. And as always, head over to the kitguru.net website where you can catch up on all the latest in-depth hardware reviews and catch up on all the latest tech news. I've been James for Kit Guru. I'll see you next time.